Hey everyone, welcome. This is the Transformative Vertical Flight Working Group for Public Services. This is meeting number 92. Today is Thursday, November 21st, 2024. Today we have a very interesting speaker, Rui Marcelino. He is the founder and CEO of Almadesign. I will introduce him shortly. First, let me go to the coming meetings. Just for a note to let everyone know, I delivered a lecture at Auburn University in November. The topic was autonomy, AI, gaming, and infrastructures. Yeah, you say, okay, how do those get together? Actually, the focus is how we leverage those on the scaling of eVTOL, Advanced Air Mobility Public Service Mission. So if anybody interested in brainstorming on that topic, let me know. We'll discuss more. And just quickly, we discussed this mostly last meeting, but the quick note on the forthcoming meeting, the AIA SciTech meeting is going to be Orlando, January 6th to 10th. CES, a lot of the technology advancement that can play a role in our effort here. It's going to be January 7th to 10th in Vegas. Of course, there's a handling quality technical meeting by Vertical Flight Society. It's going to be in January 22nd, 23rd, 2025 in Huntsville, Alabama. And also the big one, don't forget the Transformative Vertical Flight 2025 is going to take place, Vertical Flight Society annual big event, going to take place in Phoenix, Arizona, February 4th to 6th. Hope to see some of you guys there. Now with that, I'm going back to, oops, there you go. Let me introduce our speaker, Rui Marcelino. He's going to talk to us about design-driven innovation and collaboration, the third dimension of urban mobility. Rui is the founder and CEO of Almadesign. We all know that the urban air mobility has come a long way with leveraging a lot of advancements and technologies. There's an interesting program called the FlyPT project, integrating different Portuguese companies in the aviation sector, aim to push the boundaries of autonomous mobility through a demonstrator of an electric multimodal transport system that combine a drone, a passenger cabin, and an autonomous skateboard. Very interesting concept, offering both horizontal and vertical mobility simultaneously. I love to see that. Well, I want one of those, or at least having that available in our area. Yeah, Almadesign was responsible for the full industrial design project, showcasing how design can be a powerful innovation, collaboration, and integration tool. Now, Rui Marcelino is the founder and CEO of Almadesign. He's degreed in mechanical engineering, master's in transportation design, and PhD in product design management. What a background. After an experience at Central Steel Alfa Romeo in 1997, he became founder and CEO of Almadesign, a design studio dedicated to transportation, products, and interiors, responsible for the company's management and over 900 design projects. So I'm anxious to go through, let Rui go through the presentation. Please feel free to post questions in the Q&A and or just raise your hand. You can ask a question. We do reserve 10 minutes or more at the end of the presentation for Q&A. So with that, Rui, Let me unshare my screen, and the floor is yours.
Thank you. Thank you, Johnny.
Okay, I'm unsharing. Okay, you can share your presentation now.
Okay, let me try to see if I do it right. Always scary this moment. Okay, so here we are, and let me do this, the sharing. Okay, is it working?
Yes.
Yes.
Yeah.
Good.
Yes,
So you can see it? Yeah.
we can.
Great. So, with no further ado, Johnny, first of all, thank you so much for the invitation. It's a big pleasure and my pleasure to be here with you this evening, which now for us is evening already. Big pleasure for us to be here with you. Not only you, Johnny, I know I've been with Mike Hersberg a couple of times, so it's so nice to see him again. And it's always a pleasure for me. Also, it's part of my role in society to share the things that we have done, especially in an area where personally and the company is so involved. So, as you said, I take most of my time running my studio, which is named Almadesign. I'm also a professor at University of Lisbon in my spare time, if I have some. And it's where I like also to share the knowledge with future students, and sometimes where I get future people that works with me. Um, the theme of my presentation is design-driven innovation and collaboration, and it's how design and design thinking methodologies can contribute to the multidisciplinary design of innovative aircraft projects. So first of all, as usual, and also for you to understand the context of this project, a few words about Almadesign. So Almadesign has some experience in the past in designing sustainable products. We have been designing products for the mobility area and other areas for over 27 years. Um, and of course, one of the main areas that we've been involved is the aeronautic area. I'm just showing a slide with you and sharing a slide with you. Only this year, we were involved in about 20 something projects. And these include things like competitive projects, like I can mention with not disguisable pride, the all TAP Portugal interiors of the full fleet, and they are flying today. But we also are pretty much involved, and we are very passionate for being involved in new projects and concepts. One of it, which you probably know, and it's related with the area, it's the fully electric Alice aircraft that was launched by Aviation, where we were involved on the interior design from concept to mock-up construction. So the pictures that you see there, in the left, you have the design award interior that we created for them. But on the right side, you see a picture of the real cabin and the real cockpit that we have created for them. Also, we've designed not only the taxi version, but also all cabin interior variants from executive version to the cargo version and multi-purpose versions of cabin interiors. And this addressing all the time what would be the challenges of people flying in this future, more sustainable, quieter, and cleaner future aircrafts. My first cue here about design, besides industrial design, is that design also helps our clients to communicate the projects. And so we use the same 3D files that we use for the industrial design to help the clients to generate virtual showrooms and digital mock-ups so they could share with the society what they were doing and what is the aim of the project. And this is one of the things that I would like to communicate today, is this role of design, of helping to communicate what the product is about. Another project that is very much related with the area is EVE, Air Mobility, where we were involved also on the full interior design, also in some aspects of the exterior look and feel. And again, we've created it from sketches, let's say, taking consideration of the general dimensions of the aircraft, until building the full prototype in the end, which is visitable and is, let's say, going around some exhibitions around the world where you can sit, try, have this user experience of using interactive panels, like how can you calm down passengers that are flying with something that they've never used before, and how can this be, let's say, a seamless experience in their travel path. Well, just besides, and because we like a lot to work in cooperation projects, we have been involved in some clean aviation. You probably know the program in Europe. Projects, one of them is HERA, which is run by Airbus and Leonardo, and with a lot of partners for hybrid electric aircrafts. And there's a lot of competitive projects that we have been involved lately, which I will not bore you now about. But something I would like also to share with you is that our collaboration is not on aircraft design. So we don't like to call ourselves aircraft interior designers. We are mostly concerned with mobility systems. So we work from aircrafts to buses, trains, and a lot of different systems. And you can see that all these systems are related and are correlated in the passenger experience. Since we are designers, the experience is always focused on the passenger and not so much, and I know that as a mechanical engineering background, not so much on the technology. So we make the bridge between what passengers need and what technology can give. And so the mobility system is fully approached. And you can see one of our latest projects, which is the new electric airport bus, which is the Cobus. You probably have been in one Cobus, probably once in your life, because they have 70% of the share in the world. And the last 3 generations were designed at our studio. And this is part of the decarbonization of the full aeronautic system. And also, besides the nautic area, which I will not develop, because we are related with mobility systems, we have been involved in things like energy storage, supply systems, and so the holistic approach to the vehicle infrastructure is part also of our core business. Well, but as I promised, today I was going to focus especially on a specific project that is called, as Johnny just mentioned, FlyPT. And it's a project on urban air mobility. I like to call it urban and intra-urban air mobility, supported by the recent advances in technology and systems. Well, and since my other hat as vice president of the Portuguese Aeronautic Space and Defense Association, something I like, I think the thing I will like more to do that is to build consortia with my partners at the association. And so we create a consortia of companies and R&D institutions to work on these challenges of the future third dimension of mobility, integrating what we call the passenger challenge from horizontal mobility to vertical mobility, and using, of course, advanced air mobility. So we have created this concept that is based, and it's not 100% new. I think there's nothing 100% new in the world, that is simultaneously combining an autonomous aerial vehicle, which we call within the group a drone, but the car could be considered a drone itself, an autonomous automotive vehicle for road mobility, we call it the skate, and a modular cabin attached to both vehicles. So these 3 parts are the systems that integrate vertical with horizontal mobility, and that are well explained in this graphic here. What we think it's very interesting here is that by putting these 3 systems together, we not only separate the three different parts. Let's say the service, which is the cabin, the flying part, which is the drone, and the skate, which is the round part, the ground part. But we also create connection between them. And something that I found that we as a group found very interesting is that the people that are involved in road mobility usually don't get so involved with air mobility. And there are many technologies that could bridge from one area to another area. We call this cross-pollination, and it's part of what we do at Alma, which is combining knowledge that comes from different sectors to create innovation. Another very interesting aspect of this is that since the cabin used is the same, there's no discontinuity in the trip for the passenger. And that we believe this is also one of the key factors of this project. Well, this is the scheme that we used initially to organize the project into several work packages. You've probably seen similar things in your projects. And Almadesign was responsible especially for the cabin module because it was the one that was more related with the passenger itself. But as industrial designers, we ended up integrating the full project industrial design. From our previous experience in competitive projects for next year, you really need to bridge on complex projects between many specialities, from technical side to the market drivers, which are frequently separated, and people that are on these two sides have different mindsets. We believe that design helps to make these conversions. So we use our design methodologies to create in the beginning of the process a convergence between the different stakeholders. And we use three tools that I will explain very briefly. Three, let's say, design methods. So one was the morphological table. The second was sketching, which is probably more understandable. And the third was what we call a concept selection matrix. Just to give you a short example of each one, and of course it has to be visual because whatever we do here at Alma, it has to be somehow visual. We created this big canvas where all the teams, and when you see the companies that are involved, we have engineering companies, companies specialized in aerodynamics, other in structures, other in injection molding, other in power storage systems. And we put all together on generating different solutions morphologically, let's say in terms of shape, of how to address these three parts of the concept before we knew the shape that it will take in the end. So the morphological table was used for all the teams to express visually together what different options we could have. And at this stage, this is also something I find very important, is that at this stage, there is no rule for you cannot do that. This will have a lot of problems. We are just mapping. And when you are mapping, you have a full understanding about visually how things can connect and how you can choose different options to select the best solution for the project. That's what we did here with the red squares and the green squares, was a selection process by putting everything in the same page, if you want. Well, that was the first methodology that worked with these 13 partners. The second is what you expect designers to do. But design work starts much sooner than this. It starts on the requirement definition, but the sketching stage is very important. Why is that? Sketching can be systematic and can be a structured methodology that you can use in the design process to explore, let's say to diverge, but also to integrate different solutions into a given problem. And you know what? It's very fast. And it's something that you can generate, I will not say in seconds, but in a couple of hours. Something that if you use the typical and traditional that we use a lot, 3D models, it will take you ages. So our intention at this stage was to pick on all the suggestions and all requirements from our 13 stakeholders and generate as much sketches as possible. So by doing sketches, we are visualizing and putting in the same picture things that other people can comment and can contribute over. So we ended up sketching things like, will it be a blended wing? Will it be a quadcopter? Will it be a tricopter? And at the divergence stage, everything goes and everything counts. And this is a very rich stage because even if you select one concept and leave the others behind, you have a lot of information that you can go back, revisit, and recover for later studies. Of course, in the end, we also did the interior design because this is about the continuity of the mobility process. So it should be a place where people should feel as safe and as comfortable flying or traveling in road congestion. So we had to pick our knowledge from road transportation and from air transportation into different concepts. And then we got all the team together to discuss this sketch, these images, these different ideas, and put everybody to evaluate. Now, that's where I make a stop because when you look at sketches and things created by designers, some people say, I like this, I don't like that. Uh, I like this is something that's at academic level I almost never use because this is not supposed to be just for me and because there are so many other things in a drawing besides aesthetics. And that's why we use a third tool to, let's say, put people working over the ideas that we have integrated through sketches. And this is what we call a concept selection matrix. And what is that? So we have put all the pictures of the sketches that we have generated, and we have selected like 6 or 7 best solutions. And we have evaluated them by all the teams, considering the design part, meaning aesthetics, comfort, privacy, passenger interfaces, and so on, but also on the construction part, on the structure, on manufacturing, on costs, on assembly. And of course, many people in the group have very different knowledge about these topics. And we put everybody to evaluate the strengths and the weakness of each design options based on different criteria. And in the end, at this generation stage or concept generation stage, we use the 3 systems or the 3 methods together to, for one side, use the morphological table to integrate stakeholders' suggestions. From market one side, from technical to the other side, we use sketches and an image to visualize and to integrate different viable concepts. And we use the selection matrices to allow a voting base where everybody feels they are participating in the process. So the project is also theirs and they are part of the solution, and they don't create this kind of groups that say, we are going to create problems because this is not our problem. Of course, guys, in the end, there is the risk of a design committee solution, but it's very important that you have a couple of 4 or 5, let's say, management team from different areas that should be involved and help to make, let's say, informed solution in the end. From this, we have picked that the final solution. And yes, that is the time where we proceed to the 3D model. But when we advance to the 3D model, everybody knew already what was the vision of what you would get in the end. So it's much smoother the way the different actors share files, interact, because they understand the full picture of the problem instead of just knowing electronics, aerodynamics, fuel, not fuel, but energy storage. They know how it will look and feel in the end. And this for us is really one of the most important parts, which is convergence into the same vision. Of course, from this, we always do that at Alma, is making it tangible. So we proceed with the 3D model, and we have created a 1:4 scale complete model and a complete 1:1 scale model to test ergonomics, entrance, interior systems, and so on. So the seats that you see here are full scale. They were mostly built by 3D printing methodologies. Even the textiles have 3D printed parts. And the 1:4 scale model was used for tests in the field and for flying tests, also for the drone. Well, for the design people, the product is not the only part of the solution. Even the system that interacts with you is part of the experience. So even the interfaces that you create with users, would it be pilots or would it be passengers, they have to be very intuitive. And since we were talking about a transport system with no pilots, we can develop this topic later. We use the most intuitive interface that you could have. So we have developed the full, let's say, visual user experience until the final mock-up that you could see here in this image. So, and summing up, like some previous projects we have worked together, FlyPT included these three design methods to specify, to generate, and to select solutions. And the selected solution was developed successfully into a 3D model and then into building a prototype. And these methods, in our opinion, proved to be a successful tool when working with different stakeholders and specialities, even different cultures, because it's a common language that everybody understands. And finally, because the only way to succeed, well, the only way I've been doing projects in the last 27 years is through collaboration. And we believe that these design methods can be used in the development of new aircraft designs, making or new products. Of course, aircraft designs is our mostly used area, but in developing new projects and making the right bridge between different technologies and even different market trends and market needs. And from operators to passengers, from engineers to maintenance people, you can create a common language and a common vision from early stages through design methods. Finally, and I'm arriving to the end, besides the technical integration and let's say the market and technical integration, design also helps to communicate the story that is behind the project, which creates a bigger involvement of the project members and of society. It's not the first time that some clients asked us to tell a story of their products, and when you visualize the story of the product, their stakeholders and their community of interest says for the first time, now I understand what you're doing, now I understand what is the scope of your project. And it's not that the project is not a good solution, it's just that you need a good storytelling. So talking about storytelling, we have created in the end of this project with all the team, we have created a short story that could be disseminated through internet, through all channels, social networks. And we have created a small 2.5 minutes video, which I'll share with you now, if the sound goes okay, which tells a little bit of the full story of the project. And I hope the sound goes well. I'm going to try it again. You have the sound?
The
Yes,
sound
we
is
do.
good.
So this is mainly the story, and I think that the images are much more explicit than all the speech I could do about the project. And of course, I think that my two hats, three hats, the role of my at Almadesign and at university is a little bit this: is to understand how the design process and how your process can help projects, especially innovative projects with so much uncertainty, to succeed. And of course, what we want with that here at the team is always to become better designers, like Dubberly, which is an author that I've studied a long time ago, says is why do we care so much about design process? Because we want to become better designers and generate nicer things for the world and to generate a better world than the one we live in. So that's basically it. And Johnny, I think we were discussed about 30 minutes, and I think uh, I didn't pass too much. Thank you also for your attention.
Perfect time management. That's impressive. Hey, I always sometimes has a maybe an ancient perception that designer, industry designer are creative individual with armed with technical knowledge and background, uh, like the automotive design studio. But I'm learning a lot from your more systematic project-based approach. That's the metrics seem a lot more applicable to many of the new project, regardless of flying on the ground or whatever in between. That's impressive. Learn a lot from you. Thank you very much.
Thank you so much.
I do have one question as I was watching this particular configuration design. If we don't put people in the cab, is it possible for this vehicle to fly with the base, the ground portion, and to deploy into, I'm thinking about disaster response, to deploy into disaster area, then we'll ferry people in and out, and they have several ground-based units running around and deliver food, water, medicine. Just curiosity, is that even a possibility?
Man, that's a terrific question, and I'll tell you why. Because before we did this project, we've developed the same concept, which have no cart and have a movable cabin with small, let's say, movable parts, which you could do small movings into a field where it's dropped. So our scope, it was called at the time Flexcraft, and at the time we had Embraer involved in that project, and it was exactly what you were saying, which was uh, it was a flying wing, like just like this, because the scope here is to have a little bit more of range than the typical just rotor configuration. So it was a flying wing. We call it a flying wing because it dropped the pod in disaster areas and in areas where you need any. It didn't have such mobility as this one, so it would not move 20, 30 kilometers from the spot it's dropped, but it could move locally. And so it would do exactly what you were saying, which is create like you could drop a lot of these things in a
Yeah,
field
yeah.
with a
Okay.
single wing, right?
Yeah. Okay. That sounds like you have been thinking and working on something of that nature already. That's
Yep,
encouraging. That's encouraging. Hope to see some real things in the field soon
in the pipeline.
in the pipeline. Good deal. Let me open the floor. Anybody has questions for Rui?
Hey, Rui, this is Greg with Pivotal. When you do these designs of uh, these aeronautical designs, you have ergonomic concerns, but you also have weight budget concerns. How do you manage that comfortability and then that weight budget whether it be a penalty, or you're always trying to move weight out of the aircraft to make it have greater capabilities. How do you manage that from a design perspective?
Greg, that's a great question. Something I sometimes take some time to explain to people that I'm working with is that my understanding of design is design as an integration tool, which means when we start the project at the very beginning, so when we are at the requirement stage, we have a requirement database where we have weight, final target in terms of costs, everything is there.
And the aesthetics, right? You got to make it look pretty.
And of course, and aesthetics. So at different stages, you remember, I can share you later, at different stages of the process, I need also to manage my team into diversions. So weight, MTOW if you want, costs, structure analysis, aerodynamics might not be in the equation, like that morphologic table I was sharing, but that's the divergence part. And then you have to converge, which means, okay, now let's put data over it and see which concept can stand. But if you do the other way around, if you start to generate concepts with the constraints, you will not generate anything new. You will generate more of the same. You will start with the same thing. So we prefer to do the other way around, which is, guys, now you can do everything. If you don't hurt each other, you can do everything. And when you have the, let's say, full spectrum of solutions, then we put the load of constrictions over it and we start to converge, and then you're left with 2 or 3, but not anymore with the same solution as always. And this is like a schizophrenic exercise, because my background also is engineer, and my first job before Alfa Romeo, I didn't tell that to Johnny, was aircraft development for a drone in 1993, which means I remember, and it was autonomous drone in 1993, which was quite, well, nobody at my house knew what a drone was at the time. And at that time, I remember that before doing something, I had the guy from aerodynamics pulling over me and say, no, you have to have laminar flow all the way around, and so on and so on. And I said, come on, I cannot get out of this drop shape, because what's a drop shape? Because if you want laminar flow, it will be that. Well, like the aircraft I have behind, okay? So, and if you start with putting all the constraints in the first moment, man, you'll finish up with the same thing. So I even like shut myself, even if I'm looking at aerodynamics, I get my mouth shut and say, guys, this is what we want. This is the final output that we want. Just go ahead. And then when you arrive to the first stage, we get the load of constrictions. I like to share one slide that I've shared with you before, which has this. And let me show you before. I like that a lot, because it's a slide I use frequently at my university, and it's this one. You've probably seen it before. So there's a moment for divergence, and then you put constraints over it, then you converge into a solution, then you start diverging again. The thing is, if you leave space in the beginning for divergence and make this exercise in an iterative way, in the end, you will have less divergence and probably a more innovative solution. But like you're saying, just confessing you a small secret, sometimes I even use this kind of criteria to support aesthetic solutions, but you should not say that to anyone. Like, I'm saying that this air intake, it's much more efficient than having a big hole. They say, oh, put a bigger hole because you cannot have enough air. And I said, no, I have a smaller one, but it's much more efficient than the one you are suggesting. The thing is, it looks much better, but I won't tell.
That's a super answer, and covered the differences. I love what you said. If you start from over-constrained.
I think I lost Johnny for a couple of seconds. Did you?
Yes.
You're back. No.
Johnny, you back?
Well, I'll go ahead and
Mike,
ask.
go ahead.
Yeah, I'll ask my question, and hopefully Johnny comes back here. Very, very interesting design. I'm always blown away by what you guys do, and just really exciting. For the FlyPT design, I may have missed it, but did you say who that was? You did that for a customer, right? A client? Did you say who that was?
Yeah, there is a major, let's say, we work in a consortium, but there is a major integrator, which you probably have heard about, they are called TVF. I have them in a previous slide. And TVF is a drone manufacturer that builds, well, they don't have such a big drone, but they have drones up to 7-8 meters span in wings. So they are aiming to go, let's say, bigger, right? I think I have their name here. Yeah,
Okay.
it's these guys.
Oh, yes. Okay, good. Yeah, thank you. I missed that. Thanks.
No worries.
Really cool stuff.
Thank you, Ben. And Greg, by the way, this slide, for me, it's what I mean with divergence, right? So there's no one there saying, you can't do that.
Yeah, this is almost like a little menu of options, right? Or capabilities.
Yep.
When I saw that, I thought, a lot of design elements in each one of those. Very interesting.
Very cool.
And it's visual. So even people who don't understand anything can look at it and imagine the guy from production that doesn't understand anything about aerodynamics say, well, but this would be easier to produce. So he understands what we are showing.
It's part of that aesthetics across the board of all the components. Pick and choose what you want.
And I have this motto, which probably you have in your companies, which is, since I was at university doing that job as aeronautic design, which is usually an aircraft that looks good, flies well. And you know that, right?
Right. Well, Johnny, we're glad to see you back.
Yeah, I was dropped out for a second. Sorry about that.
We were able to carry on without you.
Yeah, thank you.
You're good.
Yeah, that's you're right. I mean, we said that in the industry, the aviation industry, airplane has to look good to fly well.
So this is also something good for our side, which is, I think it's a thing of our relation of perception with nature elements. When we see things from nature, they most usually look beautiful. And they look beautiful because there's some part of our brain that says that shape works well. And that works also for us with cars, with trains, with boats, with aircrafts.
Absolutely.
I have a question as well.
There you go.
Hi, good evening. So thank you, obrigada, for the presentation. One question, did you start using virtual reality to visualize all this before you go into prototypes or building them, or?
We do, Marilena, definitely. And this is something we are, especially when we are concerned, and we are very much concerned with human factors. It's in the center of the process. In the end, the human being has to be there, especially on things that relate control, like bridge. Well, the comfort is difficult to simulate on virtual reality because you don't have pain, right, with the glasses. Until now, I would say, because you can have the proper suit, okay? But I would not like to try those suits. Anyway, the thing of reachability, awareness of the things that happen around you, we will use quite often. And also we use it especially for cockpit, for instance, integration. This is very important because you can address things like accessibility, visibility, and it's so important to use virtual reality there. But we also use several stages of physical prototyping. We can start a prototype with making like a fast wood or foam prototype to check the paint part, as I was telling you. And then, okay, we check, it's okay. Then we go into 3D. Then we use virtual reality before we go to the detailed 3D model. So we save some money there as well.
Yeah.
In the end, the design process is mostly iterative, so through cycles. And we have a motto here that says, prototype as soon as you can, even with low resolution, because you get conclusions immediately. And use VR as soon as possible, because you get conclusions much sooner than if you try to do everything right, and then in the end you make it and it's wrong.
Okay, thank you. And then the second question, at what moment do you start to use certification requirements? I mean, it is said to us that you should use them as soon as early as possible.
Absolutely. So in terms of requirements, they are in the first list of requirements. And I have a motto here at Almadesign, which is before, when a client asks me to design a line, I tell them, you have first to write me 200 lines about that line, okay? Which means certification requirement, maintenance, etc. Which doesn't mean that when I'm generating such a matrix, I'm looking at certification. I'm not, definitely. But when I'm selecting, those criteria come. When I'm generating, it's again the divergence and the convergence. And of course, if we find that considering the general, let's say, level of certification, maintenance, cost, weight, etc., we are still on, maybe there are still 6 or 7 concepts that still fit. Now, we have been used in the past to certification processes of real things, like the interiors for top, everything we have generated, it has to be certified. Everything, from a piece of cloth. You have to certify everything, right? The thing is, when you're generating something in a 5 to 10 year span, when do you need to put all these constraints without knowing how certification will, in this case, advanced air mobility, will close around this topic? So it's a tricky subject. We keep it, like we say, like it comes from the first moment, but we don't put it as like the main trigger. When I'm designing for top interiors, I have 1.5 years to put that in the market. So if I choose a material that is not certified or a seat that is not certified yet, it's the end of the world. It will not be feasible. In this case, I have more freedom.
Yeah. Thank you. Yes. Thank you.
Excellent questions and even better answer. I love that. I mean, that's a really important on what stage are you in the process and how solidified some of the requirements, including certifications, are. Love you the way that you have gone through the process. You understand that what type of project, how you manage it. That's just fantastic. Any other questions? Last call. If not, I would really like to thank you again, Rui, for this excellent session. Not only the presentation was great, the Q&A was excellent. We love to follow up what you're doing, and so please keep us. Oh, wait a minute. Greg has one more question. Okay.
Come on, Greg.
I won't keep you all very long. No, I don't have a question.
No.
I was just
to be honest, I could speak about this topic all evening.
Yeah.
Tito. Yes. Thank you so much. Yeah, I really enjoyed it.
May I leave a message for you? So the most important thing here at Alma, I have 15 guys there playing, guys and women playing guitar and waiting for me to go to dinner. And it's a lovely place, 15 minutes from Lisbon downtown. If you ever are around Lisbon, I'll be delighted to welcome here at Alma to see scale models of things we have done in the past, and to meet the guys and the team, which is the best part of my team.
I'll take you up on that.
Absolutely, thank you. And with that, everyone, happy holidays.
Happy holidays for you too.
Happy holidays.